My name is Steve Gunther. I'm a power management architect with the Digital Enterprise Group in Intel Corporation. I'm going to talk with you a little bit about a new technology introduced on the Nehalem family of processors that we refer to as Intel TurboBoost technology. What Intel TurboBoost technology does is allows you to maximize the performance of the processor under a wide range of applications, under a wide range of usage conditions. So what I'm zooming in on here is a picture of the die, an actual picture of the die floor plan. And on the first version of the Nehalem family of processors, there's 4 processor cores. So 4 independent processor cores, all able to run tasks independently of the other 4. What I'm showing in this graph is 4 dials on the bottom. Each of these represents the throughput of one of those processor cores. So if I start by looking at a multi-threaded application, let's look at a 4-threaded application where each one of those processor cores is running independent applications simultaneously. And you'll see the activity on each of these cores is a little bit different. Historically, that's how we set the frequency targets of the processor. We assumed that every processor core was running a high-performance application simultaneously. That rarely happens in the real world. So the purpose of TurboBoost technology is to take advantage of the headroom when some of those cores are idle and turn that into higher frequency on the other cores. So if I'm looking at a 2-threaded application rather than a 4-threaded, on Nehalem I had the ability to turn off 2 of those cores. Those 2 cores go to 0 power transparently to the system, transparently to the operating system, and I turn that power budget into frequency headroom on the cores that are still active. The same thing applies if I go to a single thread workload. So if one of the 2 cores that was on goes off, I translate that power budget into more frequency on the remaining core. And finally, even if I'm running a multi-threaded application where all 4 of my cores are busy, but that application isn't using the entire resources of the processor, I can again translate that into more frequency on the cores that are active. What this gives me on the Nehalem processor is a capability of maximizing the performance independent of application, independent of the number of threads that are active, independent of operating systems, and it really provides a big performance boost for the processor.